Okay, so we're going over the review for chapter 3, starting with 3.1. In the diagram, they give us a picture of a um, rectangular prism, and they want us to find a couple different lines. Now, it's important to note that in the directions, they actually say that we are going to do values or lines or planes that go through point N. So it has to contain that point. Otherwise, it's not going to fit as one of the answers. So that part was a little bit confusing, especially on big ideas. Number one, they want first, again, a line that contains point N. They also want a line that's perpendicular to QR. So QR is going to be this line here. Well, the only line that is perpendicular to QR and goes through N is this line here. And they gave us a right angle symbol where they meet so that we can tell that. So again, for that one, we're using NR. So NR, and we're doing the symbols over top there. So line NR. Now, for the second one, lines parallel to QR. So again, using that same line, QR, the lines that are parallel to it. So we have 3 lines that are parallel to that. However, in order to satisfy what's being asked, they also, again, want it through or containing point N. So PN is the only one out of those 3 that satisfies that requirement. So PN is going to be our line. All right, then it says lines skew to QR. So again, still using QR here, but now we want lines skew to QR. So there's several lines skew to QR. For example, MN, KL. We also have KP and JN. Now, out of those, which one is skew and goes through N? The only one is JN. So JN is our skew line that goes through N and the skew with QR. Now, the last one, plane parallel to plane LMQ. So for this one, LMQ, LM, and Q are in this plane on this side. So we want the plane that's on the opposite side, which would be parallel to it. So we can use any of those 4 points, either K, J, N, or P. Again, pick 3 of those 4. K, J, N would be one acceptable plane. Again, the letter you could have used instead is P. Doesn't matter the order that you write them in. Number 5, identify all pairs of angles of a given type. So they give us several different things here. Let me try doing this a different way. I don't have my usual writing thing, so I'm going to try typing instead. So consecutive interior. For consecutive interior, well, we need angles that are on the same side of the transversal, but inside the parallel lines. So there's 2 that will work. It'll either be 3 and 5, or the other set is 4 and 6. Again, they're on the same side of the transversal, but inside the lines. All right, for the next one, alternate interior angles. Again, there are 2 sets that work. Alternate being alternate sides of the transversal, interior inside the parallel lines. So for this one, we have 3 and 6 is one set. The other set is going to be 4 and 5. Then we have corresponding. Corresponding angles are angles in the same position. So angle 1 and angle 5 are in the same position. But now this one has 4 sets. So we have 1 and 5, followed by 3 and 7, then 2 and 6, and then finally 4 and 8. And then finally alternate exterior angles. So 1 and 8 will be alternate exterior, as well as 2 and 7. And again, those are alternate exterior because they're on alternate sides of the transversal, but they are in between, sorry, they're on the outside of those 2 lines. So alternate and exterior. All right, so that's 3.1. Let's keep going. So now we're going to go down to 3, 2. Parallel lines and transversals. On this one, we have 35 is the only angle given to us. So we're going to use that 35 that they gave us. And every single angle in here is going to be one of two things, either congruent or supplementary. So since we have this angle that appears to be acute, that means all the acute angles in this diagram would be congruent to that. So we're going to say the angle Y there is also 35. Then for angle X, that one, well, we're not going to have the same angle because that one's obtuse. So since they're not congruent, they'd have to be supplementary. So for this one, we're going to have those two angles have to add together to give us 180. So 180 equals X plus 35. Then after that, we need to solve. So we're going to subtract the 35 from both sides. When you subtract 35 from 180, we're left with 145. So 145 is equal to X. Now, for number 10, same idea. So 48 is in the one corner. That's acute. 48 and the X value this time are in both acute angles. So those two should be equal. So now we're going to solve by saying those two equal to each other. So for X, we're going to do 48 is equal to 5X minus 17. Then we're going to solve by first subtracting the 17. So 17, oh, sorry. It was minus 17, so we need to add 17. So if we add 17, that's going to bring us to 65. So 65 equals 5X. And then divide by 5. So that's going to be 13. And we got 13 is equal to X. Next, we're going to do the same thing for Y. So for Y, we have 48 and Y are not going to be congruent because one's acute, one's obtuse. So they're going to have to equal 180. So they're supplementary. So 180 equals 48 plus Y. And then we're subtracting 48 from both sides. So it's going to give us 132 is equal to Y. So those are our answers. All right. On number 11, we have 2Y, 58, and 2X. Well, again, we have to look to see which ones are congruent and which ones are supplementary. So 58 and the 2Y will be congruent this time. Since they're congruent, we can set them equal. So we'll solve for Y first this time. So we have 2Y equals 58. Then divide by 2. So Y equals 29. Then we're going to do the same thing for the X value. So for the X value, this time, the X, the 2X, and the 58, those are going to be supplementary. So we're going to say 180 equals, we have 2X plus 58. So then we can subtract the 58 from both sides. That'll bring us down to 122 is equal to 2X. And then we got to get rid of the 2 by dividing by 2. So 122 divided by 2 is going to give us 61. And that'll be our X value. On number 12, we have the 116 is given to us. It's an obtuse angle. Again, we have one acute angle, one obtuse angle up here. So we can say that the one that has the X in it, that's also obtuse, that's going to be congruent or equal to the 116. So we got 116 is equal to 6X plus 32. then we're solving. So first thing, we're going to subtract the 32. So minus 32 from both sides, and that gives us 84 is equal to 6x. Then we can divide by 6. If we divide by 6, that's going to be 14. And that's our value for x. For y, again, kind of the same thing, except those two values, one's obtuse, one's acute, so they're going to be supplementary. So we can set them equal to 180. So 180 equals, we got the 5y minus 21. And we're adding to that the 116. We can go ahead and combine like terms. So we still have the 5y, negative 21, and positive 116. This can give us plus 95. Then we can subtract the 95 off of both sides, which leaves us with 65. Oh, no, that's too low. 85. So 85 equals 5y. Divide by 5, and we should get 17 for y. 17 equals y. Yeah. And that's it for 3.2. So now let's go down to 3.3. On 3.3, almost the exact same thing that we're doing before. So it says find the value of x that makes the lines parallel. Explain your reasoning. So for these, number 13, we have two angles that are in positions that are considered consecutive interior or same side interior. So they have to be supplementary. So we're going to write an equation so that those two angles add up to 180. Or if you just want to say that if you subtract the 73 from 180, so that's 180 minus 73, that'll end up giving us a value of 107. And that'll be our answer. On 14, this time they gave us alternate exterior angles. Alternate exterior angles are going to be congruent if we have parallel lines. So now we can set those equal. So we have x plus 14 equals 147. Subtract the 14 from both sides, leaves us with 134. And that's our answer. On 15, the two angles that are given to us are not any special type of relationship. So first we need to match them up with something that would be. So we could say, all right, this 3x would also be the same thing up here in this corner. So I'm just going to go ahead and type it in right here, 3x. Those two are corresponding with one another. Now, since that is there, we can say that the 3x and this 2x plus 20, those are a linear pair, which must also be supplementary. So we're going to set them equal to 180. So 180 equals 3x plus 2x plus 20. Combine like terms. So 180 equals now 5x. We still have that plus 20. We're going to move that over to the other side by subtracting it. So that's going to give us now 160 equals 5x. And then finally divide by 5. And if you divide that by 5, you get 32. All right. On 16, the two angles that they gave us are in the same corresponding positions. So since they are corresponding, we can set them equal to each other. So we're going to say 7x minus 11 is equal to 4x plus 58. Then we're going to solve. First, subtract the 4x from both sides. Leaves us with 3x. Then we can go ahead and add the 11 to both sides, and that gives us 69. If we divide both sides by 3, then x is equal to 2. Let's see, goes into 2, goes into that 3, so 23. So x is 23. All right. Finally, on number 17, the string of the music instrument called, so this thing up here, shown are the outer strings of them parallel. So we have this has a 93-degree angle, this has a 93-degree angle. Now, if we had named these before, and which I did give you a name for them, these are same side exterior angles. Our book doesn't cover those, but same side exterior should be the same thing as same side interior. They are supplementary angles. So here, they should not be equal in order to be parallel. They should be supplementary. So on this one, we can say for sure that no, they are not parallel. The two angles are equal, but would have to be supplementary to have parallel lines. So again, something like that would work as a good explanation. All right, so that's it for 17. That's it for 3.1 through 3.3. I'll put the rest of it in another video.